In this video module, we'll be looking at building a tandem queuing model, and the system we're modeling looks like this. We have entities that arrive. They wait in line if necessary for server 1. They're processed by server 1. They are then transferred to server 2, where again they wait in line if necessary, and they are processed by server 2, and they exit the system. The objective that we're trying to meet in this video series or in the video module is to demonstrate model building. So we're going to go quickly through the process, basically walk through the individual steps, but we're not going to take a lot of time to describe exactly what's going on. Instead, we'll do that in subsequent videos that we'll reference in the document. So in the first video, this one, we'll build the basic Simio model. In the second video in the module, we will create and run an experiment. In the third video, we will add capacitated buffers and look at something called reference properties in Simio. And then finally, we will look at the animation, some basic animation in the video 4. So let's look at some of the details of our system that we'll need in order to build the basic model. So we have an inter-arrival time, so the time between successive arrivals will be exponentially distributed with a mean of 1.25 minutes. Service times at server 1 follow a triangular distribution with parameters 1, 1.2, and 1.4 minutes. And finally, service times at server 2 are exponentially distributed with a mean of 1.1 minutes. The metrics that we're interested in, first of all, we're interested in steady state metrics. We're interested in the time that entities spend in the system, the number of entities in the system, and then the throughput. And we're going to define throughput as the rate at which entities depart the system. So we can think about this as the number of entities that depart divided by the simulation time. We have a couple of assumptions we're going to make. First of all, both servers have capacity 1. We have FIFO, or first in, first out queues, and we will initially model the system with infinite capacity queues. Then we will experiment in subsequent videos with capacitated queues where we set the queuing capacity and we end up having blocking and starving within our system. So building the basic model in Simio is very straightforward. Let's jump into Simio and get started. First of all, if you're not familiar with the Simio user interface, I suggest you stop this video and watch the module that describes the user interface so it's easier for you to follow along. And in this model, what we're going to do is use objects from the standard library. And so going back to the system we're modeling, we'll use a source object to generate entities. We'll use a server object to represent server 1, and a second server object to represent server 2, and then we will use a sync object to represent entities that complete processing. And so back to Simio, I'm going to grab my individual object instances. So there's my source, my server 1, my server 2, and then finally my sync. Let me zoom out just a little bit. There we go. And I'm going to then place my default entity instance here. And then I want to connect my objects using path objects. So I'm going to connect the output of the source to the input of server 1, representing entities that arrive and immediately go to server 1. Then I'm going to add a path from the output of server 1 to the input of server 2, entities leaving server 1 and arriving at server 2. And then finally the output of server 2 to the sync, representing the entities that have completed processing. So I, at this point, can now run my model. We haven't put any parameters in, but basically we can run under the default properties for all of our object instances. And we can see we have entities that are arriving at source 1, they're going to server 1, they then go to server 2, and they depart. We see a little bit of queuing here, and so we, at this point, are satisfied that we've implemented the model correctly. From a structural point of view, of course, we haven't put any of the properties associated with our queuing system, but we'll get to that next. So note also that while the model's running, we can move things around. So I can move my servers and my sync object around. I can also switch to 3D mode. So if I hit the 3 key, I can look in 3D mode and so on. Hit the 2 to get back to 2D mode. And we'll continue discussing the 3D mode and the positioning of object instances and so on when we get to the fourth video on animation. But for this video, we're really just interested in implementing the basic model. And so now that we have the structural components, the next step that we want to do is put the individual parameters in. And so recall that we have inter-arrival times are exponentially distributed with a mean of 1.25 minutes. Service times are triangular on the first server and exponential on the second server. So let's put those properties in. So I'm going to go to my source first, and when I select the source object instance, we can see the properties for that object instance over here on the right. And so the property we're interested in is this inner arrival time, which is set by default to be random.exponential 0.25. And so we can simply change that to a 1.25, like so. And now we have set our inner arrival time. We don't need to adjust any of the other properties. Also, as a quick note, note that the inner arrival time property is now bold, indicating that we've changed from the default properties. So then next we can go to server 1, and its default properties are random.triangular, 0.1, 0.2, 0.3, and of course we want that to actually be, or we want this version to be random.triangular 1, 1.2, 1.4 minutes. Again, bold, indicating that we have changed from the default. And then finally, on server 2, I'm going to this time use the expression builder rather than just typing that in. Again, there's a complete video on the expression builder if you're not familiar with that. And what we want to do is have random exponential and mean value of 1.1. So again, bold, representing the fact that we've changed the initial properties. Random.exponential 1.1. And so we go back and check our model one more time. We have our inner arrival times are exponential with a mean of 1.25. Server 1, triangular 1, 1.2, 1.4. Server 2, exponential 1.1. So for the other assumptions we have, in our model, in terms of capacity 1 servers, that's the default, so nothing to do there. FIFO queues, also the default. And finally, infinite capacity buffers is what we implement by default. So now we can run our model, and one thing we're going to notice that model seems to be running a little bit slower. We've actually slowed down the arrival from the default. So I'm just going to adjust the speed factor up a bit. Let's make this 25 rather than 1, and now we can see entities flowing through the system, and note the passage of time down here in the bottom. So at this point we are about half an hour in to our run. So I'm going to pause the model here. So I hit the pause button up here and just take a quick look at our run type. So we've specified the default that the specific ending time is going to be 6/9/215 12 o'clock a.m. We started at 6/8, also at 12 o'clock a.m. So by default, we're running for 24 hours. And so I can either continue to run if I just hit the start again, and I can watch time here, or I can just at any point say I want to fast forward, and we'll note that Simio runs till the end of the run. Okay, so once we have our run, we can then look at the results in the Results tab, and we can see the pivot grid representing the providing the results. And so again, if you're not familiar with the pivot grid, we have a video module that describes the pivot grid in detail. So what I want to do now is filter my results so that I can see precisely what I'm after. And so recall what we're after in our objective was the time in system, the number in system, and then ultimately the throughput. We're going to ignore the throughput, at least initially, and we'll come back to that a little bit later. So I'm going to filter to where I'm only showing the number in system and the time in system. And so that immediately reduces significantly the number of rows that we see in our pivot grid. And then at steady state, I'm really only interested in these average values. So I'm going to get the average hours. And so here we are with the average number in system of 14.165 and the average time in system of 0.2971. And so note that these results are based on one run of our model of time approximately or exactly 24 hours. So I can adjust this. I can either use a time date, or I can just simply say, for example, if I wanted to run for, say, 10 days, I could just make this a 240 hours. Similarly, or then I go back and run. I can then fast forward if I want. And now we have 240 hours. We go back to our pivot grid and we can see that we still have our filtered results, which is what we're interested in, and now our results of 11.2851 for number in system and 0.2360 for our average time in system has been determined over our 10-day run or 240-hour run. And so that's it really for our basic model. Recall what we did was we placed our source, our two servers in our sink. We then connected the object instances using path objects, and then we updated the properties for the in-arrival time, the service time for server 1, the service time for server 2, and then we modified our run conditions to run for 240 hours. We then ran the model in interactive mode, and then we're able to evaluate the results. So in the next video, we will look at creating an experiment where we actually run for multiple replications, and we also deal with an issue of warming up the simulation so that we can get to steady state.